Hi everyone, today we're going to be talking about 3D shapes and nets. So far we've been working with two-dimensional objects. Today we're moving into three-dimensional objects. We're going to be able to identify the parts of a 3D figure, find the difference between prisms and pyramids, identify the nets and shapes of 3D objects. Why do we learn this? Well, if you look around us, there are 3D shapes. We live in a three-dimensional world. We have 3D shapes all around us. We have ice cream cones. We have cylinders, spheres, like balls, Rubik's cubes. These would be rectangular prisms or pyramids. So we have shapes like this all around us, and we see them every day. So let's try to draw this shape. Now, drawing 3D shapes can be kind of difficult. One way I do it is I sometimes make I'm going to do it over here. I make a square. May not be a great square, but it's a square. And then if you make another square, kind of overlapping, like this, then you can connect your edges. That one to that one. Drawing with my mouse is not always the neatest, as you know. And this one to this corner, and this corner to this corner, and voila. You have kind of a cube. This one was kind of messy over here. We'll kind of ignore that. There's different ways you can do it, but that's one way to make a cube. A cube is a type of rectangular prism, actually, but all the faces, those are all these things here, are squares. And we have a total of 6 squares. You have one in the front, one in the back, and then 4 around the edges. So now let's talk about the different parts. So that's why we had you draw it, so you can label it. Each one of the squares on the cube are called a face. So this is a face, face, face. We have 6 faces on a cube. Where 2 faces come together, like right here, that is called an edge. Edges are line segments. And then last, we have the corners, where 2 or more of our edges meet. Those are called vertexes. They're where our edges meet. So label your parts so that you know what I'm talking about when I talk about each of those. Okay, we have 2 main categories of shapes that we're going to be dealing with today: prisms and pyramids. Prisms are made up of bases that can be pretty much any shape. In this case, our base is a hexagon. And then sides or side faces that are all rectangles. You name prisms based on their bases. Since this is a hexagon, we would name this a hexagonal. I always have to throw that O at the end. Hexagonal. Again, I'm writing with my mouse. I probably should just be writing with the keyboard. It'd be a lot neater. Hexagonal prism. I could make a prism that has squares on the end. I could make a prism that has rectangles on the ends. I could make one with triangles on the ends. You would name them either like rectangular prism, triangular prism. You can make a pentagonal prism. So whatever the base is what you name them. But the side faces are always rectangles. Pyramids, on the other hand, also have a base, but they only have one base. And the base can be a number of shapes. This one is a rectangle, and look, the word's already there, so I don't have to write it. But the side faces are all triangles. That's how they come to a point. And so pyramids are named again after their base. This one has a rectangle for the base, so it'd be a rectangular pyramid. You could have a pentagon for the base and call it a pentagonal pyramid. Any of those work. So let's talk about these ones that don't have polygons for bases at all. They have circles. This one's a cone. It has a circular base, but it comes to a point, kind of like a pyramid. This one has a circle for two bases. It's a cylinder, like a can. A sphere doesn't really even seem to have a base. It's just the same all the way around. If you cut it in half, though, you'd have a circle. Okay, let's practice naming some of our shapes. Notice that this one has rectangles, 3 rectangles, and 2 triangles. So the triangles are the bases, and the shapes connecting the 2 bases are rectangles. So this would be a triangular prism. See, I can learn. I can type now. Prism. Oops. I should have that moved, though, so you can see. This one has a triangle for a base, but it comes to a point. So this one would be, I'm going to make my font a little smaller so it can fit better. This one would be a triangular pyramid because each of the sides is a triangle. This one has a pentagon for the top and bottom base and rectangles for the sides. So if the side faces are rectangles, we are talking about a prism. So this one would be a pentagonal, couldn't fit that in there all the way, prism. And last, and it still wants to wrap. Oh well. Last 3 we have here. This one has rectangles for bases, rectangles all the way around. This would be a rectangular prism. This one comes to a point, but it's upside down. Don't let that fool you. Still has a rectangle for the base, triangles for its side faces. So this would be a triangular pyramid. And this one has 1, 2, 3, 4. These are trapezoids for its bases, rectangles all the way around. This would be a, you got it, trapezoidal. That's a weird word. Trapezoidal prism. When we have these, we count our edges, our faces, and talk about our base shapes. For this one, if I started from the beginning, my base is a triangle and a triangle with rectangles connecting them. So this would be a triangular prism. My base shape, I would put triangle. For vertices, I'm going to count my corners. 1, 2, 3, but don't forget I have 3 down here too. 4, 5, 6. I have 6 vertices. Get my pen back. How many edges do I have? 1, 2, 3, 4, 5, 6 edges. Is that all of them? No, I forgot these. 7, 8, 9. I have 9 edges. Don't forget you have them on the sides too. Now faces. You can look at faces both ways. The faces are faces also, but we're just for today going to count our non-base faces. So our sides. 1, 2, 3. We have 3 faces that are not a base. And my base, as I said, was a triangle. I'm just going to put a T for now, so save myself some time. Okay, let's look at number 2. My top and bottom, by the way, these are all look like squares to me. Can't say for sure they're squares, so I'm going to call them rectangles because they could be a little off. How many vertices do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 vertices. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. I have 4 faces that are not bases. And my base shape, you could put a square or you could put a rectangle. You can put an R for rectangle because it could be a rectangle, it could be a square. A little hard to tell for sure. Okay, my next one. What's this shape? 1, 2, 3, 4, 5. That's a pentagon. Put a P for pentagon for now. How many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15. How many faces that are not bases? I have 1, 2, 3, 4, 5. Are you starting to see a pattern here? Notice, if my base shape is a pentagon, I have 5 faces that aren't a base. Pentagon has 5 sides. I have 10 vertices, so I have twice as many vertices as I have faces. And I have 15 edges. I have 3 times as many edges as I have faces. Does that work for all of them? Yeah, you can see the 3 times 2 is 6. 3 times 3 is 9. 4 times 2 is 8. 4 times 3 is 12. It will always work when you have a pyramid. 1, 2, 3, 4, 5, 6. This base shape is a hexagon. So I should have 12 vertices. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I do. And I should have 18 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I counted all my faces, 1, 2, 3, 4, 5, 6. I have 6 faces that are not bases. Now let's look at the pyramids. This would be a triangular pyramid. My base is a triangle. I'll put my T for triangle. How many vertices do I have? 1, 2, 3, 4. That's kind of weird. How many edges do I have? 1, 2, 3, 4, 5, 6. How many faces do I have that aren't bases? 1, 2, 3. But this could be a square, it could be a trapezoid, kind of hard to tell. I'm going to say a rectangle. It's a quadrilateral of some sort. Looks like it's probably a rectangle. How many vertices do I have? 1, 2, 3, 4, 5. How many edges do I have? 1, 2, 3, 4, 5, 6, 7, 8. How many faces that are not bases? 1, 2, 3, 4. Okay, what's this one? This is a pentagonal pyramid. My base is a pentagon. Let me count them. My vertices 1, 2, 3, 4, 5, and 1 on top, so 6. My edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my number of faces that are not bases are 1, 2, 3, 4, 5. Are you seeing the pattern here? If my base shape is 5, my number of faces is 5. My number of vertices is 6, which is 1 more than the number of faces. And the number of edges is 10, which is double the number of faces. Let's see if that works. My triangle, 3-sided. I have 3 faces. 3 plus 1 is 4. 3 times 2 is 6. This one, 4 plus 1 is 5. 4 times 2 is 8. That works. This one has a hexagon for a base. So 6 sides, which means it should have 6 faces. 1, 2, 3, 4, 5, 6, which it does, which means it should have 7 vertices. One more than 6. 1, 2, 3, 4, 5, 6. And the one on top, 7. And it should have 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which it does. Next thing I want to talk about are nets. A net is when you unfold a 3D object and see what it's made up of. When we made this cube, if I unfolded this, I would get something that looks like this. You could unfold it different ways. This is just one way I could unfold it. It's made up of 1, 2, 3, 4, 5, 6 different squares. Take a while for my page to load. We have this kind of cool app that shows you how you can unfold different shapes. So if I have this shape, what do you think? I don't know what these words are and why they're there, but they are. If I folded this up, what do you think you would have? Let's take a look, see if you were right. Oops, I need to not have that. I don't want to draw on the line, I want to move this dot. Move it. Fold it up. I have a triangular pyramid. Another net for the same one, I unfolded it, can also look like this. So there's different ways you can make nets, but all of them are made up of 1, 2, 3, 4 triangles. Let's look at our next example. Okay, so I have 1, 2 hexagons and 1, 2, 3, 4, 5, 6 rectangles. Let's fold it up. I have a hexagonal pyramid. We have this activity. The link will be on Schoology, but it is a way for you to practice with your nets. It's kind of fun. You get to. One thing about this, for some reason, they call rectangular prisms cuboids. So you need to know that. They call hexagonal prisms, and they call rectangular pyramids, but for some reason, rectangular prisms they call a cuboid. I don't know why. Okay, what are these nets? Well, this one has 3 rectangles, so it's going to be, because I have those rectangles with bases, it's going to be a pyramid. I mean a prism, sorry. Prism and 2 triangles, so this would be a triangular prism. This one has 1 square base and 4 triangle faces. So this would make a square or a rectangular pyramid because my sides are triangles. This one's made up all of rectangles. I have 1, 2, 3, 4, 5, 6 rectangles. This would be a rectangular prism. This one's made up all of triangles. 1, 2, 3, 4 triangles. One of these will be a base, and the rest would be faces. So this would be a triangular pyramid. For your homework, you have a worksheet. What we'd like you to do is draw nets for each of them. You do not need to draw them like we just looked at them with them all connected. I just want you to identify all of the different shapes that make up the 3D object. So this is a rectangular prism. I have bases that are 5 by 4 rectangles. They look like squares, but they're 5 by 4 rectangles. So I want you to draw your two bases that are both 5 by 4 rectangles. You don't need to connect them. You don't need to try to figure out what it looks like when you unfold it. Just know that you have two 5 centimeter by 4 centimeter rectangles. They don't have to be drawn to scale or anything fancy. I have a rectangle over here that is 4 centimeters by 8 centimeters. And on the opposite side, one that I can't see over here, there would actually be another 4 by 8 rectangle. I just can't see it. So I want to draw those two 4 by 8 rectangles. Like I said, the drawing doesn't have to be beautiful. We just need to draw them and label them. And I have two of those. Since this is a rectangular pyramid, I should have a total of 6 sides on this thing. So I need 2 more rectangles. And they are my top. Let me draw this. My bottom down here and my top up here. And they are both 8 by 5. That is a terrible drawing the way I did this, but you get the idea. 8 by 5, and the top is also 8 by 5. So draw 2 more rectangles. Each one is 8 by 5. And those are all the shapes that make up this rectangular pyramid, prism. I'm getting my words mixed up. What shapes make up this? Looks like a right triangle right here and another one over here. So I have 2 right triangles. Oops. That is a terrible drawing of a right triangle. That's what happens when I draw with my mouse. It's sad as I have this whole nice shape here. I could actually draw the shape. 3 by 4, and my hypotenuse, this long shape here, is my 5 inches. I have 5 inches here. Say my bottom is 3, and my side is 4. Then I have 1, 2, 3 rectangles. I'm going to draw those 3 rectangles. They're not all the same size, but like I said, I don't care if you draw them to scale. We just want to know that there are 3 rectangles. This one here, we'll start with this one on top. That's all outlined in solid sides. It's 8 here and 5. So I have one that's 8 by 5. I have another one on the bottom that is 4 inches this way and 8 inches this way. That's this one right here. So it is 4 inches by 8 inches. Then my back, this one is 3 inches, again by 8 inches. 3 by 8. And I have a total of 5 faces, my 2 bases and my 3 non-base faces. So that should help you figure out how to draw these. Your homework for tonight is to look at the worksheet called Surface Area and draw out your nets. Draw them this way. Don't worry about trying to unfold them and draw them fancy. Just draw the shapes that make up the net. That is it. Other than that, you don't really have any homework. You do not need to put it in backpacks or anything. I just want you to draw your nets. Have a great night.